G'day folks, Mr. Wilcox here. I hope you guys are all having a good time tackling this assignment. I've had a few questions about some basics, and the first one here is scaling. What you're looking at is the photo I've put into Desmos, and the idea is that you find the points on that curve, and once you've found the points on that curve, you can get rid of the picture, and you've got a series of points there that you've got to fit a curve to. You're going to be trying various functions, okay? One of the questions that's come in is, but you're giving this scale here. And if I look at this here, I go from 0 to, I don't know, about 6.5 or something, 6.9, 6.8, there. Whereas this down here tells me each of these divisions is 20 centimetres. So that's not right, is it? I'm going to have to scale this thing up to get the right measurements. So if you want, you can start doing things like stretching the photo or changing and changing the scale in Desmos to get it all to fit. And away you go. Remember, you've got to do it for both axes as well. The other thought that occurred to me, though, is why bother right now? Why not just do it like that? Go ahead, and you're going to have functions. You're going to have, obviously most people are probably going to start looking at just a straight quadratic of some kind. We've asked you to look at a whole series of even degree polynomials, but I would suggest as part of the assignment that you'd want to look at some sort of odd degree polynomials, right? And have a little bit of a look at that so you've got something to compare and discuss. You do that stuff. Once you have your functions, you can stretch those functions. You can stretch them in the x direction, and you can stretch them in the y direction. Now, the amount you stretch them would be the scaling factor, wouldn't it? So if you work out that this distance here should be, I don't know, 1, 2, 3, 4, 5, say 120 centimetres, it should be 120 from there to there. But when you actually hear it's actually 6.8, well then your scaling factor, of course, is 120 over 6.8. Whatever that's going to be. And you could also, this all looks like it's going to work the same here because your scales are even x and y, but you do that for the y direction as well. Now you know how to stretch functions this way and this way. What's that called? When you're looking at a transformation, what's it called when you stretch things in that direction? That's what you need to understand, and you need to be able to apply that and explain it, and use your words like reflection, dilation, etc., transformations, all that kind of thing. That's what we've been teaching you about in the course. We expect those kind of words to come back to us on how you handle these functions. You've got all sorts of things there. You talk about the shape of this thing, etc. There's a lot there for discussion. But right now for the scaling, I'm just wondering whether if you just ignore the whole thing and put some sort of scaling factor in at the last, once you've got a function that fits, then that'll stretch it in either direction. Or the other way might simply be to play with these axes and the size of the photo so that it's all set there in the scale for you. Okay, hope that helps, guys. Let us know if it doesn't. Thank you.